Okay, so I did post a work solution to this, but it is a question that's really hard to unpick looking at a work solution. So I'm going to do a video solution. This one is going to use cast. There is a separate video that will show you it's exactly the same solution, but using a graph. So if you prefer graphs, go and find that one instead of this video. Now, there are some key facts that we need to know before we get started. As soon as I see a question like this in a non-calculator paper, the very first thing I'm doing is trying to associate back to my table of exact values. So let's just remind ourselves of that table of exact values. If you haven't got it written down, you may wish to write it down. That table of exact values includes pi on 3, pi on 6, and pi on 4. Sine of pi on 3 is root 3 on 2. Cos of pi on 3 is a half. Tan of pi over 3 is root 3. For pi on 6, we have a half, root 3 on 2, and we have 1 over root 3. And finally, for sine of pi on 4, we have 1 over root 2, 1 over root 2, and 1. Now, if you ever forget these, you can draw the triangles, you can go back to your notes, find them, but you do need to know this table. In this case, I'm seeing 5 pi over 3 and a cos, so immediately know it's going to have something to do with a half. As you go around your unit circle, as you go around your cast diagram, I should say, you get different angles which are related to pi on 3. And each time you get one of those, it will either give you a value of a half or minus a half. Now, I'll talk a bit more in depth about that. This is going to be a really in-depth kind of chat about this question rather than just a solution. Similarly, for tan of 7 pi on 4, I know my answer is going to have something to do with 1. So let's play around with this. And as I say, I'm going to talk quite a lot about this, more than you need to actually answer the question, but so that you build a bit of understanding. So what this diagram here is telling us is if I do cos of pi on 3, which is over here, there's pi on 3 degrees, then I get a value of a half. The other way that we could write this is cos of pi on 3 equals a half. Now, that means this angle here is like my relative acute angle that solves the equation cos x equals a half. And one of the options is pi on 3. If I was to look for another one, say over here, well, we know that this section here is given by pi minus pi on 3, or 2 pi over 3. That's the other way we can write that. If we're in that section and you were solving this equation, you wouldn't quite get a half because cos is negative in here. So in this section of our cast diagram, with cos of 2 pi on 3, we get minus a half. So it didn't quite give us a solution. Same thing down here. This section associates with pi plus pi on 3, which here is 4 pi on 3. And again, we get minus a half because cos is negative in that part of our cast diagram. So we kind of like an angle down here. The final angle is this one, where we start at 2 pi and we come back by a pi on 3. Now, 2 pi's is the same as 6 pi on 3. Take away 1 pi on 3. This angle here is now 2 pi, take away pi on 3 is 5 pi on 3. Now again, we're thinking the value is going to be a half, but here it was negative because cos is negative. Here it was negative because cos is negative. Over here, we're back to equaling a half because cos is positive in this part of the diagram. Now, if I'm actually answering the original question, if I'm looking back at the original question and just approaching it, this hopefully gives me some understanding of what sort of thing we're looking at. If I'm answering the original question, I'm just going straight for the answer. I'll draw my cast diagram. I'll be thinking, where does 5 pi on 3 live? Well, 5 pi on 3 is down here somewhere, because it is 2 pi minus pi on 3. Oh, therefore cos is positive, so it will have the same value as it did at pi on 3, because that was the same amount. And it is in a section of the cast diagram where cos is positive. So I could immediately go, well, cos of 5 pi over 3 equals a half. So it's kind of using our cast diagram a bit backwards to what we'd normally use it, but hopefully this gives you a sense of what's going on under the surface. Now the second one we'll just talk about the tan one and see what happens with it. So with the tan one, I'm going to do it in the kind of quick way we've talked about. So first thing I need to do is I need to think where 7 pi over 4 is. Now, as soon as I get a diagram like this, I'm thinking, oh, we're working in over 4s. So the knowing pi and 2 pi doesn't help me much. Well, pi is the same as 4 pi over 4. 2 pi is the same as 8 pi over 4. That gives me a bit more of a clue. 7 pi over 4 is exactly pi over 4 radians before that. If you're remembering pi over 4 is 45 degrees, that can help because it'll give you a clue. It's not going to be as far as this would be 90 degrees before, 45 degrees before. Yeah, we're definitely in this section of our diagram. Now, if we're over here, tan would be positive, but because we're over here, tan is negative. Because it's associated to the original kind of relative acute angle of pi on 4, that association that puts it in this section as 2 pi minus that relative acute angle means it's still going to have a value of 1, but because it's in the C section, we know it's not going to be plus 1. Instead, it is going to be minus 1. So from the fact we're in the C section of our diagram, we know that tan of 7 pi over 4 is going to equal minus 1. And finishing our question off, therefore, our original calculation there becomes a half, take away minus 1, which is 3 over 2. Now, there is another question like this in the past papers. You can work your way through and find it. They don't come up all that often, but it is useful to really get your head into a cast diagram and try and work your way through it. And hopefully this little explanation has helped you do that a bit more. If, of course, you want to see it with a graph, and maybe that'll extend your understanding, there is a video that does that as well.